trigonometrical identities of compound angles. Alright, so today we're going to have a look at what trig identities are, the common trig identities, of which there are many more in your maths book that I suggested for this course, the bird, the higher engineer math. Solving problems involving trig identities. I look at the compound angle formally and solving problems involving compound angle formula. That's our target for today. So, what are trig identities? What is the relationship in trigonometrical form that is true for all values of the unknown variables? This identity would be true for any value. Rearrange trigonometric expressions involving and problems. So, help you to rearrange trig equation. There are many identities available for use in this way, many more than we here. Many more in the bird higher engineering math. Your tutor will provide you with the laminated copy of that you need. The trig identity is the tan of sine A divided by cos A. We can prove that as follows in this slide. So, if we look at the SOHCAHTOA, if you like, for right angle triangles, the sine of an angle is B over C, the cosine of an angle is A over C, and the tan of the same angle is B over A, with that triangle labelled as it is. So if we take equation 1 and we substitute for sine A, B over C, and we substitute for cos A, A over C, so we've got this fraction divided by a fraction. Do that simplification, dividing a fraction by another fraction, we turn the denominator fraction up the other way. We'll know that. If you've got an equation of a variable and a cosine of a variable in it, and you want to use this identity, if you can sine A over cos A, if you can replace the sine A over cos A with tan A, you only got one lot of A there you can then solve for. And then hopefully we'll get an example so you can see how that works. That's an example of an identity that is always true. Any value, in this case of A, that identity cos A is equal to tan A. All happy with that? What's meant by an identity? Okay, two further trig identities. 2 times sine A sine B is equal to cos A minus B minus cos A plus B. That's number 15 on your crib sheet, I believe. Have I got all the numbers right? No, it isn't, because I've changed them. It's number 17. I typed that up and then I changed the crib sheet because I added something else to it. And cos minus A, sorry? Is that? Okay. There's two that are very similar there, take it. Right. And the cosine of minus A is equal to the cosine of A. If we think about the cosine waveform, it starts at 0 and 1. Okay. And it goes down to 0 at 90 degrees. Yeah. So if we take the cosine is equal to cosine minus just yeah. Right. Around that one it is so minus 2 pi sine meters per second. So that's the velocity of a cam operated slider at time t seconds as given by that equation. So determine the time when the velocity v is at 0. Okay. So how would we go about doing that problem? Any ideas? Well, if we want to find when velocity is at 0, so we say 0 is equal to 12 pi cos t minus 2 pi. Right. Yeah. Now, we've got an equation there. We want to find t. Yeah. So we need to get t on its own, but we've got two versions. One in cosine function, one in sine function. Can anyone see anything that we could do to that to simplify the start point? So anything common in there? Sorry? That's pi t is common to the two functions, yes. You could do, but there's something better. If you think of it like that, just isolate the two sine and cosine functions there. What could we do to simplify what's there? No, not an identity yet. What's common to these two? Yeah, so if we divide we end up with Because if we divide 0 by pi, what we got? That's handy when you've got 0 on one side, because you can divide it or multiply it by anything. So 0 by pi is 0. 12 divided by pi is 12. Cos pi t. Careful, don't divide that by inside of the right. Minus 2 sine pi. So we've got rid of the pi as a function of the two functions. What else? How can we get rid of these two? Divide by 2, good idea. So 0 is equal to 6 cos pi t minus cosine of what? Where do you think we're headed from what we've already talked about? How can we simplify the fact that we've got two functions, sine and cosine? Yes, we're trying to end up with sine pi t divided by 6 pi t. That's cos pi t, sorry. How could I think about ending up like that? What about if we need a situation where we can divide by cos pi t? We can't do that at the moment because the sine pi t is there as well. So how can we get sine pi t over the other side? With a what? Yeah. So we add sine pi t. So we write on this side sine pi t is equal to and now next thing to do I already told you. What do we want? What do we want to end up with? Sine. We want to end up with sine pi t divided by cos pi t, because then we can call it tan pi t. So we're going to divide through by cos pi t. So I'm going to write it's a 6 on this side. Is equal to sine pi t which is equal to that is by by the identity, which is number 12. Yeah. Right. So we've got this right. Tan pi t. How do I get T8? How do we get rid of the tan? What's the inverse tan function? That's minus 6 equal to pi t. Then we do what we want to find what t is. What we're going to do. I believe if you try that on your calculator, do just check 0.447. Sorry, let me get omega t minus 0.33 and 2t plus 0.67 are called compound angles because they are the sum or difference of two angles. Right. So in electrical terms, that 5 sine omega t, this is the angular frequency, that would be the phase difference. Okay, but looking at it slightly differently, difference between two angles. So the difference between that angle and the phase angle. Compound angle formulae for sines and cosines of the sum of difference of two angles A and B are. So we can express sine A plus B, sine A cos B plus cos A sine B. Similarly with sine A minus B and cos A plus B and cos A minus B. We've got these four compound angle identities. And they allow us to convert between these forms. That form and that form. We can go one way or the other, depending on what we're trying to do with the problem. Okay. Now, those formulae, all stated above, can also be used to derive two further compound angle formulae involving the tangent of the difference of two angles. Okay, it's there for completeness. Not any problems that I'm going to do with those compound angle formulae. All right, but that's there for completeness. So they're true for all values of A and B. That means they are identities. Okay, and that means whatever value we make A and B, that identity will be true. Okay, so we're going to have a look at problems involving and the compound angle formulae now. For obvious reasons. So, expand and simplify the following expressions. Sine brackets pi plus alpha. Okay, so we're looking at the identity for sine A plus B. So how can we write that in sine A plus B form? An A and B. Okay. And that's B. So we look at that identity on our sheets and we write it out in the other form. So in this case, we would sine A plus B, A, sine pi. These are terms, cosine, well, hang on, compound angle on the back, 90. Yeah, so we write that times cosine alpha. Yeah. Cosine pi times sine. So you can write it out in that form. Now can you see what we've got there? Anything we can do with that? What's the sine of pi? Think about the zero pi of 2 pi 3 pi 3 pi and it goes and 3 pi goes up there, 6 pi over 2, down 3 pi. So the sine of pi is equal to 0 now be, yeah, times cos of alpha. What's the cosine of pi? Again, on the graph, is cosine. 1 at 0, 0 at pi over 2. At pi, it is minus 1. Minus 1, yeah. So that's minus 1 cos pi times sine of alpha. Naught times cos alpha is and cos pi is Oh, that's gone. Cos by minus 1. Cosine of 0 times cosine of alpha is 0 times cosine of alpha is 0 times the cosine of alpha is 0. That's sine x. Therefore, what we had in the first place, sine pi plus alpha minus sine alpha. 0 minus 1 times sine alpha. You've got 0, take away sine alpha, you've got minus sine alpha. Have a go at B and C. Hey boys, let's just sum where we are here. So what we've done is we've let the expression to a sine wave and a cosine wave equal the r sine omega t alpha form. We've applied the compound angle from the right hand side to take the opposite. We've done some rearrangement, so we've got a r cos alpha times sine omega t, r sine alpha times cos omega t. Should be for the one for the sine. But straight away, might be, have I confused you by straight away taking r outside? Compound angle for sine A plus B. I've used sine A plus B, okay, but, so we've got sine A cos B